Hi, I'm excited that you're joining us today for our lesson on how to evaluate functions. So we're going to be looking at how to evaluate functions from their graphs and their equations. And if you're going to be working in Study Island later to see how to use these, how to do the problems there, you're going to be want to work in evaluate functions. That's what the topic is called there. So if you want more practice, that's where you can go to get more practice on these types of questions. So you have our study tips as always. So remember, I highly recommend that you be taking notes, and you can, if I go too fast, you can pause and rewind so that you can get caught back up. And then also you have the ability to pause when I start a question, work that question out, and then restart and see how you did. So I'm super excited that you're here, and let's take a look at what function notation is.
Before we start on the examples, we need to first understand what function notation is. So function notation is something that we use when we start listing out a bunch of functions or using multiple functions in a problem. So here I have 4 equations written down. And so when I'm talking about these, I could say, the first equation, the third equation, what's the difference between second and fourth? I could word my questions that way. Or the way that mathematicians have found to make it a little less complicated, just in case you copy things in a different order, or you have so many listed that you don't want to be counting out, is by using function notation. So instead of having these y's out front, we are going to have function notation. So I'm going to scratch out those y's. And now we're going to have something that looks like this. We're going to have something, it looks like f times x, but we actually read that f of x. And we could have g of x. And we could have h of x. We could have y of x. You can basically use any letter you want to out front. And then whatever variable you're using in the equation is what goes in the parentheses. So this is just a way of naming a function. So I could say in a problem, add and subtract f of x and g of x. Add f of x and y of x. And that way you would know exactly what function I'm talking about instead of having to guess. So this is just a name. This whole piece always sticks together. It's not f times x, it's just the name out front. It's another way of writing y. If it really confuses you, you can rewrite it, scratch this out, and put a y there instead. And so in these problems, they're going to ask us to find what is f of negative 2. So all that means is, do you see how this negative 2 has taken the place of the x? That just means in the equation part, I'm substituting x for negative 2. So here I'd have 5 times negative 2 is negative 10, plus 6 is negative 4. Negative 4 is my answer. That's all the more you're doing. They're just using a bit more fancier notation to ask you that question than what we might be used to seeing in earlier math classes. So in this first example, we have a function with the name f of x. It wants to find the value of f of negative 4 for the function below. So if you can see, negative 4 has replaced the x in f of x's name. So that means in this equation part, I'm going to replace negative 4 for x. So I have absolute value of 4. And then instead of writing x, I'm going to write a negative 4. And anytime I substitute, it's always a good idea to get in the habit of using parentheses around the number you're substituting, just to help keep everything straight and help you not to make mistakes, especially when that number is negative. So I just copy down the rest of the equation. And now I'm just going to simplify by following order of operations. So please excuse my dear Aunt Sally or PEMDAS. I'm going to do parentheses first. So absolute value brackets count as a type of parenthesis. So I'm going to do what's in here first. I do multiplication before addition. So I'm going to have negative 16 plus 1. Negative 16 plus 1 is negative 15. And then I'm going to take the absolute value of negative 15, which is 15. And 15 minus 7 is my last step, which is 8, which is going to be letter D. In this next problem, it's very similar. Here I have the function f of x, this is its name, equals x cubed minus 3 times the quantity x plus 5. And it wants me to find that function f when x is 3. So in the name, x has already been replaced with 3, so that means in the equation, I'm going to replace every x with 3. So I'm going to put my 3 in parentheses because I'm substituting. Cubed minus 3 parentheses, and I'm substituting in that 3 again, plus 5. So I do parentheses first, and in these parentheses I have 3 plus 5, which is 8. Then I'm going to do my exponent next. So 3 cubed is 3 times 3 is 9, times another 3 is 27. Minus the 3 times 8. Then I'm going to do multiplication next. So 3 times 8 is 24. And then last I do subtraction. 27 minus 24 is 3, which is the answer A. This next example takes it up a notch. I'm actually going to be substituting in an expression instead of just a number. So here I have a function called f of x, and it wants us to find f of p minus 2. So this p minus 2 replaced the x in the name. So in the actual equation, I'm going to replace all of the x's with the p minus 2. So I'm still going to use parentheses around everything I'm substituting. And so every time there was an x in this equation, I wrote a p minus 2 in its place. So it doesn't look as simple as it once did, but that's okay. We're still going to use our order of operations. So the first thing I'm going to do is parentheses. So inside the parentheses here, I have a p minus 2 plus 7. Well, combining like terms, I can take a minus 2 plus 7. That's going to be p plus 5. That's still in the parentheses squared plus p minus 2. Now I can't simplify anything else in these parentheses, so I'm going to work on the exponent, the square. Now remember, you do not want to just take p squared, 5 squared. It doesn't work that way. Remember, squaring means you're taking p minus 5 times itself. So this actually works out to be a FOIL problem. So I'm going to take my first 2 times each other. So p times p is p squared. Then I'm going to do my outside terms. 5 times p is 5p. Then I'm going to do my inside terms. 5 times p is 5p. And then my last terms is 5 times 5, which is 25. And then I still have this plus p minus 2 at the end. So now I just have all addition and subtraction, so I'm just going to combine like terms. This p squared, it's my only p squared, so I just copy it down. And then I have a 5p, 5p, and a plus p. Those are all p's with just a p, no exponents, no other variables, so I can combine those. Remember, there's an invisible 1 in front of this p, so I have 5p plus 5p plus 11p, or plus 1p is 11p. And then I have the 25 and the minus 2 that I can combine. 25 minus 2 is a positive 23 or plus 23. And this is all the further I can simplify. That's as small as it gets. So my answer is going to be B. This next example, we're looking at using function notation and evaluating with a graph. So here it tells you we have this function that we're going to call f of x, and that's this graph here. And it wants to know what is f at 2. So if you notice, once again, this x has been replaced with the 2. So it means when x is 2, what is the function equal to? So x is 2 right here on the x-coordinate. If I go up to the graph, that point is going to be right there. What's the y-coordinate of that point? It's 4. So that means my answer is going to be 4. It's as simple as reading the graph. Looking at another example with the graph, this one's a little bit different. This time it wants to know what is the value of x when we know that function is equal to negative 3. So up here it told us that function is equal to y, so this is just saying what is x when y is negative 3. So we're looking for x this time because it didn't give us x in the parentheses. So y is negative 3 right here. So I'm going to look left and right to see where the graph is, and it's right here. And that's where that's where the spot on the graph where the y coordinate is negative 3. The x coordinate at that point is negative 4. So my answer is negative 4, C. So I hope you learned something new today, and I'm really glad that you took the time to join us.